For billions of years, the moon has been our silent companion in the cosmos. It has guided explorers, inspired myths, and shaped the very nature of life on Earth. But how well do we really know our celestial neighbor? The moon is not just a bright object in the night sky. It plays a crucial role in Earth's tides, climate, and even the stability of our planet's axis. Without the moon, Earth's environment might be drastically different, perhaps even incapable of sustaining life as we know it. But the moon holds mysteries as well. How did it form? Why is one side always facing us? What secrets lie beneath its cratered surface? For centuries, scientists and civilizations have looked to the moon with wonder and curiosity. It has been the stage of historic lunar landings, a source of inspiration for science fiction, and now a new frontier for human colonization. In this documentary, we will embark on a journey to unravel the mysteries of the moon, from its dramatic past to its promising future in space exploration. Why is the moon so important to Earth, and what does its future hold for humanity? For as long as humanity has existed, the moon has been a source of mystery, inspiration, and scientific discovery. It has influenced ancient religions, guided travelers across vast oceans, and shaped our understanding of the universe. Keycap won the moon in ancient civilizations, myths, and legends. Before telescopes and scientific exploration, ancient civilizations worshipped the moon, believing it held divine power. The Babylonians associated the moon with the god Sin, believing it controlled time and fate. The Egyptians saw the moon as the left eye of Horus, symbolizing protection and healing. The Chinese told the legend of Chang'e, a goddess who ascended to the moon and now resides there forever. The Greeks and Romans named their lunar deity Selene/Luna, representing the moon's eternal glow. Despite the differences in mythology, nearly every ancient culture saw the moon as more than just a celestial object. It was a force of nature shaping life on Earth. But as human curiosity grew, so did our desire to understand the moon in a scientific way. Keycap to the birth of lunar science, the first observations. The shift from myth to science began with early astronomers attempting to map and explain the moon's movement. In 350 BCE, Aristotle proposed that the moon was a perfect sphere in the sky, made of a different material than Earth. In 150 CE, Ptolemy created a model that explained the moon's motion in Earth's orbit. The Islamic Golden Age, 800 to 1200 AD, saw scholars refining lunar observations, helping to create early astronomical tables. However, the biggest leap in our understanding came in the 17th century with the invention of the telescope. Keycap 3 Galileo and the moon, a new perspective. When Galileo Galilei pointed his telescope at the moon, he shattered centuries of misconceptions. Instead of a perfect celestial sphere, Galileo saw mountains, craters, and valleys. His sketches revealed lunar highlands and vast plains, proving that the moon was a rocky world, not a divine entity. His discoveries laid the foundation for modern lunar science, influencing astronomers for generations to come. The moon was no longer just a light in the sky. It was a place, a world waiting to be explored. Keycap for the space age, humanity reaches the moon. For centuries, the moon remained just out of reach, until the 20th century, when the dream of landing on its surface became a reality. 1959, the Soviet Union's Luna 2 became the first spacecraft to impact the moon. 1966, Luna 9 made the first soft landing, sending back the first images from the lunar surface. 1969, Apollo 11, the moment that changed history. The Apollo program provided humanity with the first rock samples, scientific experiments, and unparalleled insights into the moon's structure and history. For the first time in history, humans had touched another world. But was this just the beginning? Keycap 5 the moon today. What we've learned. Thanks to modern satellites, rovers, and lunar missions, we now know more about the moon than ever before. It has no atmosphere, making it vulnerable to meteor impacts. Its surface is covered in fine dust, regolith, that clings to everything. The moon is slowly drifting away from Earth at 3.8 centimeters per year. There is frozen water in permanently shadowed craters, which could be crucial for future space missions. But despite everything we've learned, many mysteries still remain. Could the moon become humanity's next home? And what role will it play in future space exploration? The moon is more than just Earth's satellite. It is a fundamental part of our planet's history, a stabilizer of our environment, and a key to understanding the evolution of our solar system. From its mysterious formation to its crucial role in Earth's tides, the moon has played an incredible part in shaping life as we know it. But as we look to the future, scientists are asking, can the moon become our next home? Keycap won the formation of the moon, a violent birth. The moon didn't simply appear in Earth's orbit. It was born from cosmic destruction. The most accepted theory is the giant impact hypothesis. Around 4.5 billion years ago, a Mars-sized object named Theia collided with early Earth. The collision ejected massive amounts of molten rock and debris into space, which eventually coalesced to form the moon. Evidence supporting this theory. Moon rocks brought back by Apollo missions have similar chemical compositions to Earth's mantle. The moon lacks heavy elements, suggesting it was formed from surface materials, not a separate planet. The moon is slowly drifting away from Earth, confirming it was once much closer. The moon is a scar, a reminder of our planet's violent past. Keycap 2, the moon's influence on Earth. Without the moon, Earth would be a very different place. A. The moon controls Earth's tides. The moon's gravitational pull creates ocean tides, affecting ecosystems and global weather patterns. Without tides, life on Earth may not have evolved in the same way. Some scientists believe early sea creatures relied on tides to transition from water to land. B. The moon stabilizes Earth's axis. The moon prevents Earth from wobbling uncontrollably. Without it, Earth's axial tilt would vary wildly, causing extreme climate changes, from frozen ice ages to scorching deserts. The moon acts as a cosmic anchor, keeping Earth's rotation stable for billions of years. Without the moon, Earth could be a world of climate chaos, unable to support complex life. Keycap 3, the moon's mysterious dark side. Unlike Earth, one side of the moon always faces us, while the other remains hidden. This is due to tidal locking, where the moon's rotation matches its orbit. The near side is smooth, with vast plains called Lunar Maria, ancient lava flows that cooled billions of years ago. The far side, also called the dark side, is rugged, heavily cratered, and very different from the near side. Scientists believe the far side may hold clues to how the moon evolved. It has thicker crust and no lava plains, possibly due to uneven heating after its formation. It may contain pristine records of early solar system impacts, since it has remained untouched for billions of years. What secrets are hidden on the far side of the moon? Could it help us unlock the history of the solar system? Keycap for the moon and future space exploration. Today, the moon is no longer just a scientific curiosity. It is a gateway to the future of space exploration. A. Why are we going back to the moon? With new lunar missions on the horizon, the moon is once again at the center of space exploration. NASA's Artemis program aims to return humans to the moon by 2025. China and Russia plan to build a permanent lunar base in the 2030s. Private companies like SpaceX and Blue Origin are developing technology for long-term moon missions. But why return to the moon when we've already been there? B. The moon is a launch pad for Mars and beyond. Scientists see the moon as a stepping stone to deeper space exploration. Lower gravity makes it easier to launch missions from the moon than from Earth. Lunar resources, like water ice in permanently shadowed craters, could support fuel production for future Mars missions. 3D. Printed habitats using lunar dust, regolith, could provide sustainable shelter for astronauts. The moon could be our first home beyond Earth, a testbed for living in space. Keycap 5, can humans live on the moon? The challenges of lunar colonization. With the harsh lunar environment, living on the moon is far from easy. Temperatures range from minus 173 degrees Celsius minus 280 degrees Fahrenheit at night to 127 degrees Celsius 260 degrees Fahrenheit during the day. There is no breathable atmosphere. Astronauts must rely on oxygen systems. Lunar dust is electrostatically charged and dangerous, clinging to equipment and spacesuits. B. The psychological challenge. The moon is completely isolated. A lunar base would require mental resilience and careful planning to ensure astronauts' well-being. Long-term exposure to low gravity could cause bone and muscle loss, requiring new medical solutions. Surviving on the moon will be one of humanity's greatest challenges, but also one of its greatest achievements. Keycap 6. The future. Could the moon become a second Earth? While the moon will never be another Earth, it may become something just as important. A research hub for studying the solar system, a refueling station for interplanetary travel, a permanent human settlement, proving that life beyond Earth is possible. The moon is not just a satellite. It is the first step toward a future where humanity is a multiplanetary species. For decades, the moon was considered a conquered frontier. After the Apollo missions, humanity turned its focus elsewhere, to Mars, asteroids, and deep space exploration. But today, the moon is once again at the heart of humanity's cosmic ambitions. With modern technology, international collaboration, and the rise of private space companies, a new era of lunar exploration is beginning. Keycap 1. The Artemis program, NASA's return to the moon. In 1969, Apollo 11 made history. In 2025, NASA's Artemis program aims to do it again, this time to stay. Artemis I 2022. An uncrewed mission tested NASA's Orion spacecraft and the Space Launch System, SLS. Artemis II 2024. The first crewed flight around the moon in over 50 years. Artemis III 2025 will land the first woman and the first person of color on the moon. But Artemis is not just about landing on the moon. It's about building a sustainable lunar presence. Artemis is humanity's first step toward permanent space settlement. Keycap 2. The Lunar Gateway, a space station around the moon. NASA and its partners, ESA, JAXA, and CSA, are building the Lunar Gateway, a small space station orbiting the moon. It will serve as a staging point for deep space missions, including future trips to Mars. Unlike the International Space Station, ISS, the Gateway will be outside Earth's magnetic field, allowing scientists to study long-term space radiation effects on humans. The Gateway will transform the moon into a true launch pad for the solar system. Keycap 3. The Lunar Economy, mining and resources on the moon. The moon is more than a destination. It's a potential gold mine of resources. Water ice, found in permanently shadowed craters at the moon's poles. Essential for drinking water, oxygen production, and fuel generation. Helium-3, a rare isotope that could fuel nuclear fusion reactors, providing limitless clean energy. Rare metals. The moon may contain valuable materials like titanium, platinum, and rare earth elements for future technology. Could the moon be the key to Earth's energy crisis? Keycap 4. Private companies and the new space race. Governments are no longer the only players in space exploration. Private companies are redefining how we explore the moon. SpaceX's Starship will be the primary lander for Artemis missions, capable of transporting humans and cargo to the moon and beyond. Blue Origin is working on a permanent lunar base and resource utilization projects. China and Russia have announced plans for a joint moon base by the 2030s. The future of the moon is not just about exploration, it's about colonization. Keycap 5. The challenges of colonizing the moon. Living on the moon is one of humanity's greatest challenges. Even with technology, survival on the lunar surface is difficult. A. Harsh conditions. No atmosphere. No protection from radiation or micrometeorites. Extreme temperatures, ranging from 127 degrees Celsius (260 degrees Fahrenheit) in the day to minus 173 degrees Celsius minus 280 degrees Fahrenheit at night. Lunar dust, fine particles that can damage equipment and cause health issues. B. Psychological and social challenges. Lunar settlers will be isolated for months or years, facing psychological stress. Communication with Earth has a 2.5-second delay, making real-time interactions difficult. If we can survive on the moon, we can survive anywhere in the solar system. Keycap 6. Could the moon become humanity's second home? In the coming decades, the first lunar colonies may be established. Scientists envision self-sustaining habitats with 3D printed buildings, greenhouses for food, and nuclear reactors for energy. The moon could serve as a training ground for Mars, testing life support systems before sending humans deeper into space. The moon is not just a destination. It is the first step toward a multi-planetary future. Keycap 7. The next 100 years. What's beyond the moon? The moon is only the beginning. With successful lunar missions, humanity could take the next step. Missions to Mars, using the moon as a launch pad. Asteroid mining, extracting resources beyond Earth. Deep space colonization, creating settlements in the asteroid belt, moons of Jupiter and Saturn, and beyond. The moon is our gateway to the universe. What comes next is up to us. For billions of years, the moon has been Earth's silent companion, a witness to our planet's birth, evolution, and rise of civilization. It has inspired myths, guided explorers, and now it stands as our gateway to the stars. From ancient myths to modern science, the moon has always captured our imagination. But today, it represents something even greater, our first true step toward becoming a spacefaring civilization. We have studied the moon, but its mysteries are far from solved. We have walked on the moon, but the real journey has just begun. We dream of living on the moon, but the challenge of colonization still lies ahead. What once seemed impossible is now within reach. The moon is not just a rock orbiting Earth. It is our stepping stone to the cosmos. As we prepare to return to the moon, build permanent settlements, and launch deeper space missions, one question remains. Will the moon be our first home beyond Earth, or just the beginning of something even greater?